got homework done, you can go ahead and put it away. I hope you found it helpful when you were working on those graphs and tables to be able to visualize our equations and our formulas a little bit better. Go ahead and take out your books. You can leave them closed for right now and take out a piece of paper. You're going to want to take some notes. We have some keywords that we're going to look at today that you want to be sure that you remember. But first of all, this whole time we've been working with equations, we've been looking at problem solving. We spent a few days working on problem solving, taking those puzzle pieces and putting it together to figure out what the answer was. They weren't our typical problems, they were algebra problems that we had to solve with words. So what is the first few steps to solving our word problems, Mark? Great job. He said we are to identify our unknown and to find out what it is that we're looking for. And what is the very last step anytime we have an equation, and especially when we have our word problems? Maya, do you remember that last step when we have equations?
To check.
Make sure you stand when you say your answer.
To check.
That's right. We always want to check our work. Why not check when you can make sure your answer is right so you don't lose any of those points? Now, when we have a variable, what does the variable represent, Hannah?
Some unknown.
Some unknown. That's exactly what I was looking for. Anytime we have a variable, we know there is something that we don't know. It could be chairs, it could be tables. We've talked about that. We have no idea what it could be, and that's why we have it represented as an unknown. And then our last question, this was one from yesterday. We talked about our formulas and our tables. Why do we need a formula? What does that help us do, Joy? Great job. We're going to be using those in the days to come. But for now, we're going to turn our attention today on something a little bit different. Up until this point, we have been doing a lot of arithmetic, and we've been using our arithmetic in our algebra. But we've only really dealt with numbers that were from 0 on. We haven't really looked at anything below 0, and we've always identified 0 as meaning nothing. Maya, if you have $0, well, how much do you have? How much money do you have?
None.
She doesn't have any money if she has $0. If Hannah has 0 pineapples, how many pineapples do you have to eat?
0.
0. So we usually think that 0 means empty, or none, or we don't have any. But 0, when we get to algebra, 0 means something totally different. It's almost as a reference point for us. How many of you have a thermometer maybe on your porch at home, or maybe on the shed at home? My dad always had a thermometer somewhere, and then when we got with the times in technology, he got one of the ones where we could come inside and it would tell what the outside temperature was inside our house. And up here I have a picture of a thermometer, and we can see that this man is really cold. Now we're here in Florida, and it doesn't really ever get freezing cold. But when I was growing up and I didn't live in Florida, sometimes it would get really cold outside. And I never saw it get 0 degrees, but I had family that lived way up north. I know, Hannah, your family was originally from Maryland, and so I know it gets very cold up there in the wintertime. And maybe, have you ever heard your mom or dad talk about it being 0 degrees? She said not quite. You have to go pretty far north to get 0 degrees, but we can see that 0 on our thermometer actually means something. If we say it's 0 degrees, that doesn't mean there's no temperature outside. That is not a thing. We know there's always temperature, and we can even go below 0. Sometimes in Alaska, it'll be 50 degrees below 0, and that means it is very, very cold. We've never seen temperatures like that here in Florida, but it's very real. If you walk outside and you go out in the -10-degree weather, and you're going to see that it's very cold. You're going to want gloves and a hat. It's actually something that can be measured, because it is, with 0, it's just a divider on our thermometer. So we can see that 0 is kind of like that cutoff, and you know after 0, it's going to be very cold. Well, this is almost like a number line, but I have a number line over here. And I have my 0 that, again, is a real thing. We have 0, and I know you're thinking, well, I still have 0. That means nothing. But it can be in algebra. We can extend our number direction, as far as you can think, the biggest number you can think of, it keeps going, and it also keeps going this way. It doesn't just stop at 0. Now the numbers on the other side of 0, on the left side of 0, we call those negative numbers. It almost looks like a minus sign, but we call it a negative number. So if they're on the left side of the 0, those are going to be called negative numbers. That is a word you'll want to write down and you'll want to remember. So if these are negative, you might be thinking the opposite of negative is positive. If they're on this side of the 0, these are our positive numbers. When we have a sign, we have a little dash, that's our negative sign, that shows that this is negative. So what about the positive numbers? We don't really have anything for those. Well, we could write positive number. Hannah, make sure your eyes are up here. We could write a positive number as a positive 3. And we could read that and know that that is positive 3. The same way on this side, we could write and have our negative sign, and it would be negative 3. Now, you probably noticed I'm calling these signs. This is a positive sign, and these are a negative sign. So now that we're in algebra, these numbers take on a new name. These numbers are called sign numbers. Maybe you've heard of sign numbers before. Whenever you hear the word sign numbers, we're talking about numbers that have signs that tell us what they are. And again, you're probably looking at these and thinking, well, isn't that a plus sign? Does this look like a plus sign to some of you all? It looks like a plus sign to me. And this kind of looks like a subtraction sign. So now we have two things that we need to keep straight. Sometimes, I don't know if you have ever thought about this, sometimes we have words in English that mean two things at one time. The word can means two things at one time. I can do something, but I might have a can of beans too. And those are not the same things. Well, up here we have a negative sign, but that may also sometimes be an operator sign. What is an operation? What's an example of an operation, Maya? Make sure you stand.
Multiplication.
Multiplication, we have division, so we know our operators are multiplication, division, subtraction, and addition. So let's look over here, and we're going to look at this and see if we can tell the difference. So I would read this one as 16 plus a negative 3. Well, how did I know that? I know that this is our operator. So I could go ahead, I'm just going to put an O above that because that means operation, this plus sign does. But this negative right here is telling us what direction it's going on our number line. So if I started at 16, which I don't have over here, it would be way over here on my number line, it would be telling me to go back 3 places, to go back 3 marks, and that is how we know it is our direction. So I'm going to put a D up here because that is telling us what direction it's going in. We have another example. I'm going to read this as a negative 9 minus a positive 4. You could read it as a negative 9 minus plus 4. But we've never had anything like that. We don't say minus plus 4. We never say 4 times divided by 9. And that doesn't work. So that's how we can kind of tell which way it's going to work. So the way I just said this, is this negative or is this a minus sign? Is this an operator or a direction sign, Maya?
Direction sign.
It is a direction sign, and she's right about that. Okay, what about this one right here, Hannah?
An operator.
It is an operator. That's telling us what we're doing with our numbers. So I'm going to put my O, and then lastly, Mark, what is this for us? Is that an operator or a direction? It is a direction. It's telling us that it is 4 on the other side of 0. So go ahead and look in your books, open them up to page 152, and let's look at numbers 1 through 8. We're going to do number 1 and number 2 together. So I have 6 plus 8. Well, that's pretty simple. Is this going to be an operator or a direction sign, Joy? It is telling us that it's an operation. Because if we just have directions, we've got to know what we're doing with it. And that's why it's simple enough that it is our operation sign. Number 11, that says 11 minus, I said number 11. Number 2, that says 11 minus 4. Mark, what do we have with our sign that's right there in the middle? What is that telling us to do? He's telling us to subtract, and he's exactly right. That means it's an operation. So go ahead and do 3 through 8 at your books. You should circle the ones that are direction and box the ones that are for operation. It shouldn't take you very long. Once you're done, you can put your pencil down and look up towards the board. Mark, make sure your feet are on the ground. Okay, I think y'all should have finished them up by now. We should have enough, you all have had enough time to get them done. So let's go ahead and look at it. We already did number 1 and number 2. Now I put number 3 up here on the board. So Maya, go ahead and stand and tell us, what did you box, what did you circle?
I boxed the minus sign and then I circled the negative with the 2.
Better yet, come on up here and do it for us, what you had on your paper, so that way we're not confused. She boxed the minus sign, and she was saying the way we say them can kind of give us an indication as to what they are. Great job, Maya. I hope that your paper agrees with her. Hannah, go ahead and come up here and do number 3 for us. Show us what you boxed or circled. You can spit that gum out and see me after class. Okay, thank you, Hannah. Go ahead and tell us, why did you circle what you circled, and then why did you box what you boxed?
I circled the addition sign in front of the 5 because it's directional, and same thing with the minus sign in front of the 8, and then I boxed the plus sign in the middle because it's operational.
It is operational, it's telling us what to do. Great job, I agree with Hannah, 100%, very good job. Now, let's look at this last one. I went ahead and did number 8, and we'll fill in the ones in a moment. I had 16, and I wanted to box this one. Did everybody box the minus sign? All right. And then I circled that one. I circled that negative because it's telling me which direction that it's going. On number 5, you should have boxed the first plus sign. And you should have circled the minus or the negative by the 6. Number 6, you should have circled the first sign, boxed that second sign, and circled the last sign. So you should have had a circle, a box, and a circle. And then number 7, you should have circled the first one and boxed the second one. Now let's talk about, we've looked at our positive numbers and our negative numbers. And we've already said that if we have a positive 3, we know that this is understood. We can take that positive away, and we know that it means it's positive. If I say 2, Maya, you automatically know that I am saying 2, a positive 2. We only have to say negative if it's a negative number. So positive, you can take it or leave it. And most of the time, I don't tell someone that I have a positive $15. You don't say that. You just say, I have $15. So we're going to look at something different. We're going to look at distance. Now, if I'm building a house, can I have a negative 10-foot kitchen, Mark? No, we don't have negative distance. Can I have a swimming pool that is negative 4 feet deep? That makes no sense. So our distance is always positive. We always have, if we have distance, we know it's positive. Even if I'm going this way, even if I'm going to the left, it's still a positive number because it's distance. Even if I take a few steps backwards, I still walked 3 feet. It doesn't really matter what direction it was. So we have something that's called absolute value. And what absolute value is, it's the distance that a number is from 0. So I'm going to write that up here. We have absolute value. And I said absolute value is the distance that a number is from 0. So if I have negative 3, I'm going to put a little circle right here. I have a negative 3. Everybody look with me, and we're going to see the distance that it is from 0. Well, we would go 1, 2, 3. But remember, we said the distance is always positive. So the absolute value of a negative 3 is 3. Now, we have a very special way to know when we're talking about absolute value. I can't just give you this negative 3 and expect you to know I want absolute value. But anytime you see 2 parallel bars like that, it's telling you to add, well, it's actually not telling you, it's asking you what is the absolute value. So if the absolute value of negative 3 is 3, what do you think the absolute value of negative 10 is going to be, Hannah?
10?
It is going to be 10. And what's the absolute value of 7 going to be, Maya?
7.
That's right. So our absolute value is always going to be positive. You want to make sure and that you keep that in your brain. Absolute value is always, always, always going to be positive. If you get an absolute value that's negative, then something didn't go right. We didn't get something exactly right. So we always know, because distance is never negative, absolute value is never, ever negative. So that is our absolute value. Go ahead and look at problems 19 through 20 on page 152. If they're always positive, we know that we're taking whatever number they give us and taking the sign away. So go ahead and do number 9 through 20. That should take you maybe 30, 45 seconds. That should be very quick because you're just getting rid of the sign and keeping a positive number. Yes, Maya?
I'm going to use the restroom.
You may. Okay, everybody should have finished that one up. There really wasn't a whole lot of arithmetic or thinking that had to go on that one. That's just we had to know that we had to take our sign and go through it. So we're going to go down through the rows, and I'm just going to go down through each row, and you're going to tell me what you got. Starting with number 9, what did you get, Hannah, on number 9?
7.
Great job. On 10, Mark? 11, Joy? 12, Aloha? 13, we're back to you, Hannah.
9.
That's right. Number 14 should be 1. 15 should be 6. 16 should be 3. Joy, what'd you get for 17? 18. Maya is not here. We'll go ahead to you, Tiffany. 17. 19 is 19. And 20, Mark. 20. That is exactly right. So absolute value should be one of the easiest things that we're going to do in algebra. You know that we're just going to take that sign off and you have it. I remember when I learned absolute value and I thought it was so neat because it's almost impossible to get the wrong answer if you just take your sign and take the number that you had. Let's go ahead and look at number 21 through 26. These are giving us words. We've been talking about our word problems. They give us words, and we need to learn how to work with those words so we can solve those puzzle pieces. So go ahead, and what you're doing is writing how you would say, how you would write what that sentence is. So go ahead, and let's look at 21 together. If it said negative 14, Hannah, your eye should be up here on the board. If it says negative 14, I would write it like this. If it just said 14, I would write it like this. Hannah, why don't I write a positive right there?
Because it's understood.
It is understood. So if you write it like this, it doesn't change your answer. It's just a different way we can write it. Go ahead and work on 15 through 22 through 26. And those shouldn't take us very long either. You're just going to read what they have there. Thank you. Maya, we're doing 22 through 26. You're just reading it and writing what they're telling you the number is. Okay, y'all should finish that one up. That one shouldn't have taken us very long either. Let's go ahead with number 22, and it says a positive 6, so you should have just written a 6 because we don't have to write that positive. The next one said 5 above 0. So what did you write for that, Maya?
I just wrote 5 and a degree sign.
Okay, so you wrote just a 5, and that's exactly right. Why? Don't sit down just yet. Why was it a positive 5?
Because it's above the 0 line, not below it.
That's right, so it's above the 0, so we automatically know that's a positive number. Now the next one is a different one, and it says 8 below 0, so you should have written a negative 8 degrees, because if it says below 0, you automatically know we're going to have a negative number. The next one said positive 25, so you should just have 25, and 26, you should have had negative 48. Now, in the last one of this section, we're going to look at 27 through 32. And I really like these because these are giving us something that is kind of lifelike. It's something that we can apply our negative and our positive numbers to. So our first one says, 27 says a 15-yard loss in football. Well, if it's a loss, Mark, is that going to be a positive or a negative? And he knows football. He knows it's going to be a negative if we lost yards. So we would write negative 15. Go ahead and read 28 through 32 and fill in what you think they would be. Hannah, please do 28 and 29 at the board. You'll just write out, you don't have to write out the sentence, just write out your answer. Maya, you'll write out 30 and 31 at the board. The rest of you read your problems and answer them diligently. Okay, you can go ahead and stay there when you're done. I think everybody else is finishing up. So, Hannah, you had number 28. We'll go ahead and start with that while Maya finishes this last one. 28 read 1,200 feet above sea level. Tell us what you had.
So since it's above sea level, it's positive, so I have a positive 1,200.
And then 29.
Was 12 degrees below 0, so it's a negative 12.
That's great. You can erase those and have a seat. If you can see when we're reading these problems, you have to look for the information around the number so we know if it's positive or negative. Have a seat, Hannah. Maya, go ahead and do 30 and 31 for us.
For 30, I just wrote a gross profit of $25 just means a positive $25, so I just wrote $25.
Great job, because if it's a profit, then we know it's a positive.
And then a loss of $12, I just wrote the negative sign and then $12.
Great job, because it's a loss. We know we're going to subtract. And then number 32, $100 withdrawn from the bank. Well, if you're taking money out, then you're taking away from what you had. So we know that that would be a negative $100. So we've looked at our numbers. We've looked at absolute value, how to tell our positive and our negative numbers. But what about numbers that are on the number line, and this is coming back kind of to distance. It's how we can tell what numbers are larger. We know if I say that I have 12 pineapples and Hannah has 4 pineapples, who has the most pineapples? Well, I do, because I have 12. And we know that. Y'all know how to do which numbers are larger than others when they're on the right side of the zero. But what about when they're on the other side? What about when they're on the left side? If I can erase that, clean that up a little bit. What if I had a -2 and I had 5? How do we know which number is bigger? Well, one way you can always know which number is bigger, it's the one that is on the right of the 0. So for y'all, the 5 is on the right of 0, correct? So we know that 5 is greater than the -2. But what if you had 2 negative numbers? What if you had -2 and -4? Well, now we don't have either one of them on the other side of the 0. So you're going to look at and see which one is closer to 0 or which one is the farthest right. So you're always going to look for the number that is the farthest right on the number line. Maya, would you rather owe somebody $2 or $4?
$2.
She would rather owe $2 because that is less than the -4, but it's actually a bigger number because it's getting closer to 0. So we would have that -2 is a bigger number. It's greater than -4. Go ahead and look at our practice problems on page 153. We have 1 through 6, and they've given us a number line. So you're going to look at those numbers. You can put a little X or a little circle on them and see which one is the farthest right, and that's how you know which one to circle. That's how you know which one is the greater number. Those shouldn't take you very long once you plot them on your number line and look at which one is the farthest right or the closest to 0 if they're both negative. Let's go ahead around the room. Hannah, what number did you circle for number 1?
7.
Number 2, what did you circle, Tiffany? Great job. Number 3, Mark. 11. Number 4, Aloha. Great job. Number 5, Joy. And then over here to you, Maya. Number 6, which number did you circle?
+5.
You circled the +5 because it was the farthest on the number line. Now, we have worked with some of these signs before, and if you don't remember, then we can refresh really quickly. We know that these signs are greater than and less than. And we know that specifically this one is our greater than number, and we know that this one is our less than. So this is greater, this is less. I always remember, when I was in elementary school, I had the hardest time remembering greater than and less than. I don't know why, but I just could not remember. But I remember that the greater number is always going to the right, because we've talked about how the number that is farthest on the right is the bigger number, and the number that is pointing towards the left is going to be the smaller number. It's going to be less than. So if I had 1 and I had 6, I would put a less than in here because we know that 1 is less than 6. And we've done these before with our positive numbers, but what about if we had negative? What if I have a -4 and a -1? Is -4, is it going to be less than or greater than? Well, we know that -1 is the one that's bigger because it's closer to 0. So number 4 is less than -1. We have a few of those to do on our practice problems. Let's do 7 through 12. All you're doing is filling in greater than or less than on your papers. Look at those. If you need to look at the number line, you can see which one is the farthest right, and that's the one that's greater than. Okay, let's go ahead. We're gonna, once again, just go around the room and you're gonna say if you put greater than or if you put less than. Remember, greater than is pointing to the right and less than, the pointer is to the left. So number 7, Hannah, did you have greater than or less than?
Less than.
That is correct. Number 8, Maya.
Greater than.
That's correct. Number 9, Mark. Great job. Number 10, Tiffany. Number 11, Joy. And then number 12 should have been less than. Now let's take a look at number 18 very quickly, and we'll see that we had something a little special with these. We had a positive 9, and we had a positive absolute value of 6. Now we could go ahead and label this greater than or less than with our absolute value signs, but remember, I like to simplify before we do anything. So we're going to go ahead and simplify. What is the absolute value of 9, class? 9. And what's the absolute value of 6, Hannah?
6.
It is 6. So now we can go ahead and fill in. And Maya, is this going to be greater than or less than? 9 is greater than 6. That is exactly right. Great work today with our sign numbers. We're going to continue learning those and working with those. We're going to learn some very special rules in the future. But go ahead and take out your homework notebooks. You're going to do sharpening skills 1 through 16 even. And be sure to see me after class, Hannah.